The competency in this lesson is derive inductively the relations among chords, arcs, central angles, and inscribed angles. This is just part 1 because this competency covers so many things. Specifically, we will be talking about chords, radii, and segments related to circles. First, let's have some definitions. A circle is a round plane figure whose boundary consists of points equidistant from a fixed point. This is the fixed point. It is called the center of the circle. We can name this point as point O, and we call this circle as circle O. A radius of a circle is a segment connecting the center to a point on the circle. So this is a segment connecting the center to a point on the circle. We can name this point here as point A. Now, line segment OA is a radius of circle O. A segment whose endpoints lie on a circle is called a chord. So the endpoints here are on the circle. We can name the endpoints as point B and point C. Now we can say that segment BC is a chord. A chord that contains the center of the circle is a diameter of a circle. So this chord here contains the center of the circle. So we can name this endpoint here as D. We can say that segment CD is a diameter of circle O. We have 3 theorems in this lesson. So this is the first one. Radii of the same circle are congruent. So line segment OA is a radius, and line segment OB is also a radius. So because they are radii of the same circle, we can say that segment OA is congruent to segment OB. This is another theorem. The perpendicular from the center of a circle to any chord bisects the chord. So if this is the perpendicular from the center of circle O to chord AB, this means PA equals PB. This is another theorem. The line joining the center of a circle to the midpoint of any chord which is not a diameter is perpendicular to the chord. So if this is the line segment joining the center of circle O to the midpoint of chord AB, which is not a diameter of circle O, so since it's joining chord AB to the midpoint, this means PA equals PB. Since PA equals PB, so we can say that line segment OP is perpendicular to line segment AB. Now let's talk about distance of a chord from the center. Example number 1. Given that line segment AB is equal to 8 cm and the radius of circle O is 5 cm, find the distance between line segment AB and point O. So this is our solution. First, let's draw line segment OA. This is the radius. Then we are also going to draw line segment OC, which is perpendicular to line segment AB. So we can draw this one. Now we have a right triangle. Since the radius is 5 cm, this means line segment OA is 5 cm. Since line segment AB equals 8 cm, so this means AC equals 4 cm. Now we have a right triangle here. So in a right triangle, we find the missing side by using Pythagorean theorem. So this is Pythagorean theorem. So the meaning of this is, in a right triangle, the square of the hypotenuse, or the longest side, equals the sum of the squares of the two other sides. So our C here, or the hypotenuse, is the line segment OA, and we can assign this line segment OC as our A, and this line segment CA as our B. So we have this, the quantity OA squared equals the quantity OC squared plus the quantity AC squared. OA equals 5 cm and AC equals 4 cm, so we have 5 squared equals the quantity OC squared plus 4 squared. And we know that 5 squared is 25, and then 4 squared is 16. Now subtracting 16 from both sides, so 25 minus 16 equals 9. So we have 9 equals the quantity OC squared. To get rid of the squared here, we are going to find the square root of both sides. So square root of 9 is 3. This means that line segment OC equals 3 cm. Now, let's solve a problem about finding the length of a chord. Example number 2. In the figure on the right, OA equals 13 cm and OC equals 5 cm. Find AB. So first, let us label. OA equals 13 cm and OC equals 5 cm. We have a right triangle here, so we can find AC using Pythagorean theorem. So this is the Pythagorean theorem. C squared equals A squared plus B squared. The meaning is, in a right triangle, the square of the hypotenuse, or the longest side, equals the sum of the squares of the two other sides. So our hypotenuse here is OA, and we can assign OC as our A and AC as our B. So we have the quantity OA squared equals the quantity OC squared plus the quantity AC squared. Now OA is 13 and OC is 5. So we have 13 squared equals 5 squared plus the quantity AC squared. Now 13 squared is 169 and 5 squared is 25. So we have 169 equals 25 plus the quantity AC squared. Now subtracting 25 from both sides, so 169 minus 25 equals 144. So we have 144 equals the quantity AC squared. To get rid of this squared here, we are going to find the square root of both sides. The square root of 144 is 12. So this means AC is 12. Now since AC is 12 and CB equals AC, so that means AB equals 24 cm. So this is our answer. AB equals 24 cm. Now Let's do a problem about finding the length of a radius. Example number 3. In the figure on the left, OC equals 8 cm and AB equals 12 cm. Find OA. So this OC equals 8 cm and AB equals 12 cm. Now we have a right triangle here, so to find the missing side we are going to use Pythagorean theorem, and this is the Pythagorean theorem. The meaning is, in a right triangle, the square of the hypotenuse, or the longest side, equals the sum of the squares of the two other sides. Here our hypotenuse is OA. Then we can assign OC as our side A and AC as our side B. So we have the quantity OA squared equals the quantity OC squared plus the quantity AC squared. Now our OC is 8, and since AB is 12, that means AC is 6. So we have the quantity OA squared equals 8 squared plus 6 squared. 8 squared is 64 and 6 squared is 36. So we have the quantity OA squared equals 64 plus 36. And 64 plus 36 equals 100. So we have the quantity OA squared equals 100. To get rid of the squared here, we are going to find the square root of both sides, and the square root of 100 is 10. So that means OA is 10 cm. Thanks for watching, guys. This is teacher Rejil. Keep safe.